Next concept is area of a triangle. Area of triangle. So the result is, suppose ax1 y1. Suppose ax1 y1, ex2 y2, comma cx3 y3 are the vertices of a triangle. Are vertices of a triangle. Then area of triangle ABC is equals to, formula is 1/2 into here mod x1 y2 minus x2 y1 plus x2 y3 minus x3 y2 plus x3 y1 minus x1 y3. This is the formula for area of the triangle formed by 3 vertices. You should memorize this as the formula. So to memorize, I will give one method. So first you write, how to memorize the formula means, first you write like this, x1 y1, vertices you write like this, x1 y1, x2 y2, x3 y3. Again you write x1 y1. You repeat the first coordinates again, x1 y1. Now to memorize this one, you put the cross mark like this. And like this. Then after, see here 1/2 you write 1/2 into, see x1 y2 minus x2 y1. This is the first bracket, plus x2 y3 minus x3 y2. This is the second bracket, plus x3 y1 minus x1 y2. This is the third one. So just if you memorize this one, you can write the direct formula. x1 y1, x2 y2, x3 y3, x1 y1 again. Like this, like this, like this, and like this. So clear? Right.
Yes, sir.
Now we will try to prove this result. So to prove this one, so what is, see, suppose y-axis and x-axis. So this is the triangle ABC. Here the vertices are ax1 y1 and bx2 y2, and this one is cx3 y3. So this is y-axis and x-axis is origin. Now what I do is, from this B, I will drop the perpendicular on x-axis. If you drop the perpendicular, you call this as some B dash. And you draw the perpendicular, drop the perpendicular from C and x-axis, you call this as C dash. So this angle is 90 degrees, this is angle also 90 degrees. Next, what you do is, you drop the perpendicular from A on x-axis. So you call this as A1. Now, our required area is what? Our required thing is the area of the triangle, that is this inside area. This is our required area. So this is our required area. Area of the triangle formed by the ABC. Now what I do is, to find this area, right, we will write. So area of triangle ABC, area of triangle ABC is equals to. So before writing the area, now tell me, what is this B dash A dash distance?
x1 minus x2.
Yeah. So because this distance is what? X coordinate of A. and this distance is x coordinate of b dash. That's why this distance is equal to x1 minus x2, right? So this distance is x1 minus x2, and similarly this distance is equal to x3 minus x1, x3 minus x1, because this distance is x3 minus this distance is x1, therefore this is x3 minus x1. So now what I do is, area of the triangle ABC is equal to area of triangle, area of this C dash C A dash C dash, means what I have written, area of C1. I started here, C1 C A1 again as A dash C. So this area is this one, plus I will write this area next. So that is equals to plus area of, what is that, tell me? You start from here, A1 A B B dash A dash, like that. So area of A dash A B B dash A dash. So this is, this sum plus this sum is what? This total area. This area plus this area is the summation. So but our requirement is this one. So what you need to remove from this total area, we need to remove this part. Then you will get the required area of the triangle. So minus, so this one minus area of, what you need to remove, C1 C B B1 C1, like that. So you remove that one, that is area of C dash C B B dash C dash. Remove this one. Now see, now if you observe this one here, this is one trapezium. Sir, this is another trapezium. So what is the area of the trapezium? 1/2 times sum of the parallel sides into height or not? So this
Yes.
is one trapezium. Yes, trapezium area we know. What is the trapezium area? 1/2 into sum of the sides. This side is y1. This side is what? Y3. Yes, y3. Yes, y3. Height is what? This one, x3 minus x1. Clear?
Yes, sir.
Right. So this is equal to 1/2 into, here this is y1 plus y3, sum of the parallel sides into height. Height is here x3 minus x1. x3 minus x1. So this represents what? Area of trapezium. And this is sum of parallel sides. Sum of parallel sides. So this one is height. So this is the area of the trapezium. Similarly, area of the another trapezium. Second trapezium is equal to what? 1/2 into, here sum of the parallel side, that is y1 plus y2 into height is x1 minus x2 or x2 minus x2. So that is 1/2 into y1 plus y2 into height is x1 minus x2. Similarly, third one is also a trapezium. Yes, sir. So the sum of two trapeziums minus this third trapezium. So that is also trapezium. That is equals to what? Minus 1/2 into y3 plus y2 into x3 minus x2. x3 minus x2. So that trapezium area, if you remove, then you will get. Now, if you rearrange the terms, you will get this result. Okay, I will not. Okay. You take out 1/2 outside and rearrange the terms, you will get this form. This is the proof. Okay, na?
Yes, sir.
So that is 1 by 2 into, you write the result here. That is the formula. So now what you do is, now we can put this area formula in terms of determinant. In last class, I explained what is the determinant, 3 by 3 determinant. So in future, you will learn the determinants. After learning the determinant, we can find the area of the triangle without using this formula. Just you can calculate the determinant and you can find the area. That's why we can put this area in terms of determinant. Therefore, area of triangle ABC is equal to mod of delta. Delta stands for area. Mod means positive because area never be negative. Mod of delta, where determinant may be negative. For few matrices, determinant is negative. For few matrices, determinant is 0. For few matrices, determinant is positive. But area never be negative. That's why area is equal to mod of determinant, where delta, that is determinant, is equal to 1 by 2 into, you write the like this, x1 y1 1, x2 y2 1, x3 y3 1. So you calculate this determinant, that is the area. So here these are the vertices, x1 y1, x2 y2, x3 y3. Here you put 1 by 2. So already we have seen the expansion of the determinant in last class. X1, you remove this row and this column, x1 into y2 minus y3. If you expand like this only, you will get x1 into y2 minus y3 minus y1 into, you leave this row and this column, x2 minus x3. Like this. Again, you will get the same form. That's why area is determined. You can memorize this one. Okay, na?
Yes, sir.
Next note.
Sir, can you want to?
Okay.
Yes, sir, you can cut.
Right. Next note. Note number 1 is, if x1 y1 comma x2 y2 and x3 y3 and x3 y3 are present in anti-clockwise order, on coordinate plane, then delta will be positive. And if they are present in clockwise order, and if they are present in clockwise order, then delta will be negative. That is, suppose here, suppose this is the triangle ABC. Here this is the triangle ABC. Now suppose if the vertices, if taken anti-clockwise sense, that is A, B, C. Yes or no? If you take the vertices like this, then delta will be what in this case? You get positive. If you take the vertices in anti-clockwise sense, that is A, B, C. If you take like this, then here delta will be what? Negative. That's it. Okay. But area never be negative. So for area, always we will take what? Mod of delta. See. So mod of delta is the area of the triangle. So this is the first note. Next, note number 2. Note number 2. If points A, B, C. If points A comma B and C are collinear, then delta will be equal to 0. Or delta is equal to 0 means this determinant becomes 0. x1, y1, 1, x2, y2, 1, x3, y3, 1 will be equal to what? 0. Why, tell me, why delta is equal to 0 if A, B, C are collinear? Because if A, B, C are collinear means if A, B, C lie on the same line, triangle will not be formed. Triangle will not be formed means area of the triangle is equal to what, 0 or not? That is the reason.
Yes, sir.
This is the formula for area of the triangle. That's why if A, B, C are collinear, then this determinant becomes 0 because the determinant is related to what? Area. You need not to write 1 by 2. If this becomes 0, 1 by 2 into this anyway becomes 0. That's why if this is 0, then ABC are, so ABC are collinear, this is 0. So converse is not true. Converse may not true. Yes or no? I will explain why that is so. Just this side only memorize. If ABC are collinear, then delta equals 0. Because area is 0. Because with collinear points, no triangle will be formed. That's why area is 0. Right. So next question. Find the area of the triangle. Find area of triangle formed by A 2, 3. So B 4, 5. C C 3, 2. So this is the question. So solution. So here A x1 y1, B x2 y2, C x3 y3. So method 1 is what? Directly by using the formula. So what is the formula? Area of the triangle formula. This one. So area of the triangle formula will take this one. The help of that formula. So this is the area of the triangle. Just you put the values. So area is equal to what? 1 by 2 into mod x1. What is x1? 2 into y2 is what? Y2 is 5 minus x2. x2 is 4 into y1. y1 is 3. Is the first bracket. The second one is, so x2 is 4 into y3. y3 is 2 minus x3 is 3 into y2. y2 is 5 plus x3. x3 is 3 into y1. y1 is 3 minus x1. x1 is 2 into y3. 2. Calculate this one. That is 1 by 2 into what you get? 10 minus 12 plus 8 minus 15 plus 9 minus 4. So which is equals to 1 by 2 into 10 minus 12 is minus 2 plus 8 minus 15 minus 7, 9 minus 4 plus 5. So that is 1 by 2 into minus 8, minus 9 plus 5. That is nothing but 1 by 2 into minus of what? 4. That is nothing but 4 by 2. That is 2 units. So this is the answer. So otherwise method 1, if you use the determinant, so that is delta is equal to 1 by 2 into, or you can start like this, 1 by 2 into x1 y1, that is 2 3 1, x2 y2 1, that is 4 5 1, 4 5 1, x3 y3 3 2 1. So already I explained how to find the determinant in last class. So 1 by 2 as it is. into what you need to do. So 2 into, leave the column, row and column which contains 2. So calculate this determinant, that is 5 into 1 minus 2 into 1. So that is, this is 2 into 5 into 1 minus 2 into 1. Alternate signs, plus minus plus. Minus 3 into, leave the row which contains 3 and column. Therefore remaining is 4 into 1 minus 3 into 1. Plus 1 into, leave the row which contains 1 and column which contains 1. Therefore 4 into 2 minus 5 into 3. So that is nothing but 1 by 2 into 1 by 2 into this is 2 times 5 minus 2 minus 3 times 4 minus 3 plus 1 time 8 minus 15. So 8 minus 15. So 1 by 2 into, what is this, 2 into 3 minus 3 into 1. So this is minus 7. So which is equals to 1 by 2 into 6 minus 3 minus 7. That is 1 by 2 into 6 minus 10. So which is equals to what? Minus 4 by 2, which is equal to minus 2. But what I said, delta is not an area. Delta is determinant. But delta area is what? Here I have given the formula. Area is what? Mod of delta. That's why area is equal to mod of minus 2. Therefore, area is equal to mod of delta. That is nothing but mod of minus 2, which is equal to 2 units. 2 square units. Okay, na? Is the example. So next question is, find alpha if some 1 comma 2, next 3 comma minus 5, and alpha comma 2 alpha, sorry, alpha comma 2 alpha plus 3 are collinear points. Are collinear points. So this is the question. So just before we have seen, if the points are collinear, then area is equal to what? This determinant equal to what? 0 or not? So this one equal to 0. If A, B, C are collinear, this delta is equals to 0. So now, therefore, we impose that condition, then we find the value of alpha. So now what we do is, here if you impose the determinant equal to 0 condition, then therefore delta is equal to 0 or determine y delta. Right, this is the condition is what? X1 y1 1, x2 y2 1, x3 y3 1. This is the condition. This must be equal to 0. So here 1 2 1, next 3 minus 5 1, and alpha comma 2 alpha plus 3 comma 1. This must be equal to 0. So that is 1 into, alternate signs here, plus minus plus 1 into minus 5 into 1 minus of 2 alpha plus 3 into 1. So this is the first bracket, minus of 2 into, leave the row and column which contains 2, then what you get? 3 into 1 minus alpha into 1 plus 1 into 3 into 2 alpha plus 3 minus of alpha into minus 5. So this is equal to what? 0. So this is equal to minus 5 minus 2 alpha minus 3. This is the first bracket. Minus 2 into 3 minus alpha. This is the second bracket. Plus 6 alpha plus 9 plus 5 alpha is equal to 0. Now this is equals to minus 8 minus 2 alpha minus 6 plus 2 alpha plus 6 alpha plus 5 alpha. What is this? 11 alpha plus 9 is equal to 0. So minus 2 alpha plus 2 alpha cancel. Here you left with what? 11 alpha plus what is this? 8, 6, 14, 9, 5. Minus 5 or not?
Yes, sir.
11 alpha minus 5. So 11 alpha minus 5 is equal to 0. Therefore, alpha is equal to 5 again. This is the answer. So if the 3 points are, the given 3 points are collinear, then alpha is equals to 5 by 11. This is the answer. Is it clear?
Yes, sir.
Right. So next one. Suppose see, it's a polygon with vertices A1, A2, A3, A4, etc. So this one is AN. Sir, this is a polygon with vertices A1, A2, A3, etc. up to AN. So let A1 comma A2 comma A3 comma etc. AN is a polygon. Is a polygon with vertices. Polygon with vertices. Polygon with vertices in order. AX1 Y1. Sorry, A1 X1 Y1 comma A2 X2 Y2 A3 X3 Y3 etc. up to AN XN YN. Then area of the polygon, then area of polygon can be given as area of the polygon can be given as area is equal to 1 by 2 times. So area is equals to 1 by 2 times mod of here x1. Now how to write this one area similar to that area of the triangle. So what you do is first you write this x1 y1, x2 y2, x3, y3, etc. So last one is xn minus 1, yn minus 1. Last one xn y1. Again you write the first one x1 y1. Then the same process like this. Then after like this. So if you write, then first bracket is equal to what? x1 y2 minus x2 y1. So plus second bracket is what? x2 y3 minus x3 y2 minus x3 y2 plus etc. So this bracket xn minus 1, this one xn minus 1 into yn, last word but one bracket, xn minus 1 into yn minus yn minus 1 into xn plus last bracket is this one xn y1 x1 y. So this is xn yn minus xn y1 minus x1 yn. Okay. So this is the area of the polygon form. So clear this one?
Yes, sir.
So this you memorize as the formula.